If you have ever wondered what the deadliest bomb in the world is, or if it has even been developed, here is the answer you have been seeking. Despite having billions of weapons at its disposal, the United States Air Force is still as relentless as ever in the search for lethal weapons that would make others look like child's play. The United States, known to be at the forefront of technological advancement and has proven its position in the world of advanced technology over and over again, already set aside billions of dollars to build something really outstanding: the Dragon Bomb. What makes this bomb the deadliest ever created? Has this rapid bomb ever been used in any war? Join us as we go into details about the deadliest rapid Dragon Bomb that the United States Air Force is testing. Yes, the deadliest bomb has been developed, and it is none other than the Rapid Dragon Bomb that is being tested. The Rapid Dragon is a palletized and disposable weapons module which is airdropped to deploy flying munitions, typically cruise missiles, from unmodified cargo planes. Developed between 2020 and 2021 by a team of U.S. Air Force and industry expert, Lockheed Martin Rapid Dragon is a system that has all its abilities packed into a disposable pallet. This means a regular military cargo plane can turn into a standoff strategic bomber whenever needed, and then go back to its usual transport tasks. The airdrop-rigged pallets, which is also referred to as deployment boxes, provides a low-cost method that allows unmodified cargo aircrafts, such as C-130 or C-17 aircraft, to be temporarily repurposed as standoff bombers that is capable of mass launching any variant of long or short-range AGM-158 JSM cruise missiles against land or naval targets. These deployment boxes can be in different sizes, holding from 4 to 45 AGM-158B JASSM-ER cruise missiles. These missiles can hit targets from 570 to 1,200 miles away with precision. In 2024, there will be even more JASSM-ER missiles with an even longer range. The Dragon Bomb project was named after an ancient Chinese weapon called Ji Long Che. This weapon has the ability to shoot many long-range crossbow missiles at once from a safe distance. Similarly, the present Rapid Dragon system aims to overwhelm a target's defenses from a safe distance, where the launching aircraft is not in danger. It can be quickly used, using existing fleets of transport planes, allowing for significant increases in mass attack missions at low cost and training. This bomb would allow the United States to quickly provide a strategic strike capability to its foreign military partners that already have the ability to airdrop supplies from cargo planes. It also expands the places where aircraft carrying cruise missiles can operate from, making it harder for an enemy to cripple the operator's strike aircraft fleet by destroying their established air bases. While a B-52 Stratofortress needs a 10,000 feet concrete runway, a C-130 can operate from 3,000 feet stretches of less developed surfaces. In addition to improving United States Air Force capabilities when targeting an opponent, the Rapid Dragon idea will allow other air forces that are without strategic bombers, but with transport aircraft, to launch a large number of JASSMs simultaneously. For instance, a C-130 aircraft can use the Rapid Dragon to launch about 12 JASSM cruise missiles from a safe distance of 620 to 1,180 miles away from the target. This is possible with the help of 2 Rapid Dragon pallets. The larger C-17 is large enough to carry 5 Rapid Dragon pallets, each holding 9 missiles for a mission, with a total payload of 45 missiles having 1,100 warheads. In a test over the Gulf of Mexico on December 16, 2021, an armed Rapid Dragon received target data while in flight from a distant control center. It used the data it got to target its armed JASSM, got it airdropped from the aircraft, and successfully released its payloads with the live missile hitting its naval target. The other 3 bays of the 4-pack pallet carried ballast rounds of the same shape and weight to check how the system prevents missile releases from conflicting. These non-munition ballast rounds will continue to be used for missions needing fewer missiles than the module's full capacity, ensuring stable drops. During the test, The cargo fighter jet, AMC-130J, was piloted by an Air Force Special Operations Command operational flight crew, and the aircraft carried over 4-pack version of the Rapid Dragon missile module. The airdrop crew handled the load like a standard supply drop, with the Rapid Dragon's control unit autonomously receiving command and control data for programming the JASSM's targeting data. From past experiences, we know that even the latest air defense systems struggle to defend against lots of cruise missiles coming all at once. This happened in the 2018 Riyadh missile strikes in Yemen and the 2018 missile strikes in Syria. Because high-tech air defense systems like S-300 and S-400 are not very good at stopping many low-flying cruise missiles, Rapid Dragon seems like a good choice for missions where lots of JASSM-ER missiles are used. It can work together with a bunch of small fake drones released from another module to confuse and overpower the enemy's air defenses. The U.S. Air Force plans to keep testing Rapid Dragon with C-17s, AGM-158C LRASM, and the AGM-158D JSM-XR, which has a range of 1,200 miles and became available in small numbers in 2021. The Air Force's Strategic Development Planning and Experimentation Group is also looking into using Boeing's less expensive but shorter-range JDAM-ER bombs with a range of 50 miles and is collaborating with Raytheon to help Rapid Dragon launch ADM-160 mailed decoys. In November 2022, the first live demonstration of a joint air-to-surface standoff missile in Europe took place with an MC-130J at Andøya Space Test Range in Norway, supported by military partners from Poland, Norway, Romania, and Britain during the Atreus 2022 military exercise. The system has worked well on C-130 and C-17 cargo planes, hitting both land and sea targets using armed and test versions of JASSM-ERs. In the future, they plan to expand the system to include more than just AGM-158 missiles. They want to use JDAM bombs, sea mines, drones, and other missile systems. They also aim to make the launch system work on different types of supporting aircraft, not just cargo planes. The current version uses unmodified cargo aircraft, while missile deployment requires no additional crew skills beyond those for airdrops of supplies or vehicles. The system can be thought of as a smart and disposable bomb bay in a box that includes an interface allowing targeting information that is gathered from Allied units in the target area to the munitions from a distant fire control center. In November 2022, during the yearly NATO air-sea exercise Atreus 22-4 near Norway, the new Rapid Dragon missile system made by the famous American company Lockheed Martin was introduced. The pallet was loaded into a conventional MC-130J Hercules military transport aircraft for the exercise. With the help of roller guides, the pallet Rapid Dragon was pushed to the opened in-flight cargo hatch of the plane, and then the parachute of the pallet pulled it overboard. The main parachute opened, and the pallet hung from the sling so that the missiles were in an upright position. Then they fell out of their cells one by one under the action of gravity. Then they unfolded their wings, started their engines, and rushed to their program targets at 575 miles an hour. The idea of launching cruise missiles from transport or even passenger planes is not new. In the 1970s, the U.S. Air Force was seriously considering the idea of a missile-carrying aircrafts based on the Boeing 747-200. Cruise Missile Carrier Aircraft, abbreviated CMCA, was to carry 50 to 100 AGM-86 ALCM air-launched cruise missiles on drum-mounted launchers inside the fuselage. Squadrons of such missile carriers were to continually patrol the air borders of the Soviet Union in readiness for a massive strike. The main argument in favor of the CMCA project was its price. A missile carrier based on the world's most famous airliner would have cost mere pennies to build and operate. The CMCA project was not implemented because Pentagon generals, who received good encouragement from the military-industrial complex, feared that if it succeeded, Congress would slaughter funding for the promising B-1B supersonic bomber. But the idea remained popular. In Iraq in 1991, the Americans used military transport planes as improvised bombers, dropping pallets of bombs. In Afghanistan, military transports were used to drop super-heavy GBU 43B Moab anti-bunker bombs. And finally, the Rapid Dragon. By the way, the project owes its name to a Chinese weapon thousands of years ago, a design that allowed you to shoot several crossbow bolts simultaneously. The design of the Rapid Dragon is literally ridiculously simple. It's a perfectly ordinary transport pallet for a forklift. It can even be made of wood. Rack and pinion rocket rails are mounted on it. Depending on the requirement, one pallet can hold from 6 or up to 9 weapons. If less is dropped, ballast is placed in the empty cells. Up to 2 6-round pallets can be loaded into the hold of the C-130 Hercules, and the larger C-17 Globemaster can carry up to 5 9-round pallets, which is 45 rocks. The pallets are loaded into the hold of the military transport aircraft as a normal load in flight. They're discharged through an open tail hatch with a small extraction parachute. The extraction parachute pulls the pallet overboard along roller guides, after which the main parachute opens, the pallet stabilizes, hangs on the slings, and then begins to drop missiles one by one. The Rapid Dragon currently operates with the AGM-85 JASSM-ER cruise missiles. This subsonic stealth cruise missile was designed to give tactical aircraft, fighter bombers, and attack aircraft the ability to hit protected targets from a safe distance. The original version was equipped with 1,000 pounds highly explosive and penetrative warheads. It flew 230 miles. The ER version has a larger fuel tank, and this feature automatically increases the flight range from 230 miles to 575 miles. The missile is guided by an inertial guidance system and GPS guidance. It is also guided with an infrared target identification system. During the exercise that was conducted in Norway, missile targeting was done from EI ground outside the aircraft's line of sight, making use of a satellite link. This performance demonstrated the ability to target and redirect the missile even when the fighter jet is in motion. After careful consideration, the United States has decided to make use of a long-range, short-range AGM-158D JASSM-ER cruise missile. The missile is an upgraded version of the JASSM-ER. It features a new wing design, and its range will be about 1,200 miles. The small-scale production of this missile started in late 2021, and full-scale production at a rate of 5 missiles per month is expected by the end of 2024. The second variant, the AMG-158, is an anti-ship short-range cruise missile. It is a second variant of the JSM family that is specifically designed to find and engage ships in the open sea. A long-range anti-ship missile has a range of up to 350 miles. It uses only passive sensors, infrared matrix camera, and radar detector to find the target and can coordinate with other missiles in a salvo. The third option the United States Air Force is considering is the JDAM-ER guided gliding air bombs, representing a hinge set of folding wings, rudder planes, and autopilot with GPS. JDAM-ER kits are put on conventional unguided aerial bombs, giving the ability to accurately engage targets up to 80 kilometers, depending on the drop altitude. The integration of JDAM-ERs on the Rapid Dragon is of particular interest because such munitions are extremely cheap and provide the ability to precision carpet bomb dispersed targets, such as concentrations of troops, from a safe distance. That is what the Russians are doing now, but they only use one bomb at a time, and in the case of the Rapid Dragon, a whole swarm of bombs would fall on the enemy. The fourth option is to make use of the Quick Strike ER guided mine planes. These mines are JDAM-ER type bombs. They are conventional high explosive bombs equipped with planning and guidance kits and additionally equipped with a Quick Strike digital non-contact detonator that allows them to be used as sea-bottom mines launched from an aircraft. These gliding mines can reach the minefield deployment area by themselves and land in designated positions. This allows them to mine enemy waters from beyond the range of air defense. Finally, a fifth option is the ADM-160 mailed autonomous decoys. These small-sized imitation drones are designed to mislead enemy air defenses and are capable of accurately reproducing the radar signatures of various aircraft from the F-35 stealth fighter to the B-52 strategic bomber. The latest models, the MAL-J, also have electronic jamming systems that can be used to jam radar from a safe distance. With the help of this Rapid Dragon bomb, every heavy military transport aircraft can be regarded as a strategic rocket bomber. The simplest implication is that the US has just increased its fleet of bombers, missile carriers, from 116 units. This is the 58 B-52H and 58 B-1B to 786 units, including C-17 and C-130. It would cost, well, maybe a couple of $1 million rather than tens of billions. And that's not all. To use the B-52 bomber requires a concrete runway length of at least 3,000 meters. The C-130 heavy transport aircraft can take off from a 910-meter dirt track. Controlling exactly where and what forces the US Air Force has deployed becomes virtually impossible. This system represents an opportunity for NATO, or simply friendly countries that do not have their strategic aviation, to acquire one. For example, JASSM and JASSM-ER missiles are now in service in Australia, Poland, and Finland. Australia has 30 C-17, C-27, and C-130 heavy transport aircraft capable of carrying the Rapid Dragon. Poland has 5 Hercules. By outfitting their Hercules with Rapid Dragon trays, these countries gain the ability to launch massive strikes with low-visibility cruise missiles over 2,500 miles away. This radically strengthens their capabilities, changing the regional balance of power. Another bomb that is referred to as the deadliest aside from the Rapid Dragon is the Tsar Bomba, also known as the King of Bombs. It was a huge Soviet nuclear bomb that was tested over Novaya Zemlya Island in the Arctic Ocean on October 30, 1961. It holds the record for being the largest nuclear weapon ever detonated, creating the most powerful human-made explosion ever recorded. During the tense Cold War between the Soviet Union and the United States, a group of Soviet physicists, including Andrei Sakharov, built this 3-stage bomb to demonstrate Soviet strength. Originally designed to have 100 megaton capacity, it was considered too risky to test due to the dangerous fallout. Therefore, it was adjusted to have a 50 megaton yield, which was still estimated to be about 3,800 times stronger than the US bomb dropped on Hiroshima during World War II. The Soviet scientists also modified the fusion process to reduce the fallout significantly. The resulting Tsar Bomba weighed 27 tons, with a length of around 26 feet and a diameter of about 7 feet. Although officially named RDS-220, it gained various nicknames, with Tsar Bomba being the most famous in the West. A 295V bomber was changed to carry Tsar Bomba. The bomb had a special parachute to slow it down so the plane could fly away from the explosion safely. Andrei Dernovtsev piloted the plane, taking off from Kola Peninsula on October 30, 1961. Another plane joined as an observer. The Tsar Bomba was dropped over the Mityushika Bay test site on the empty island of Novaya Zemlya around 11 a.m. Moscow time. It exploded about 2.5 miles above the ground, creating a mushroom cloud more than 37 miles high. The flash of the explosion was seen about 620 miles away. The damage caused was massive. The village of Severny, 34 miles from the explosion, was flattened, and buildings more than 100 miles away were said to be damaged. Another bomb which fits perfectly into this class is the B-61 nuclear bomb. It is the main thermonuclear gravity bomb in the US enduring stockpile since the Cold War's end. It's a strategic and tactical nuclear weapon with a 2-stage radiation implosion design. The bomb has a variable yield, meaning it can be adjusted from 0.3 to 340 kilotons in different versions. It is designed with various fusing and delivery options suitable for air and ground bursts, free fall, retarded free fall, and laydown delivery. Weighing around 700 pounds, it's 11 feet 8 inches long, with a streamlined casing for supersonic flight. The bomb is currently undergoing its 12th modification, and as of 2020, each B-61 cost $28 million. The bomb is flexible and can be adjusted for different power levels, known informally as dial-a-yield. It serves both tactical and strategic purposes and is designed to be carried by fast aircraft. With a sleek design for supersonic flight, the original B-61-0 was 141.6 inches long and weighed 715 pounds, with later versions staying similar in size and weight, except for the Mod 11, which is about 1,200 pounds. To arm the bomb on the ground, personnel use an access panel with dials, sockets, and a T-handle for the Command Disable function. This mechanism involves entering a numeric code, turning a dial, and pulling a T-shaped handle to disable the bomb, making it inoperable. The B-61 can be set for air or ground detonation, and it can be dropped with or without a parachute for various delivery modes. It can be released at high speeds and low altitudes. The Mod 11 is a specialized version designed for penetrating the ground before detonating, particularly effective against fortified structures. About 50 Mod 11 bombs have been produced, starting service in 1997, primarily used by the B-2 Spirit aircraft. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.